One more daily life application of differential equation. The water has boiled up to 100 degrees centigrade and the surrounding room temperature was 26 degrees centigrade. After passing 10 minutes, its temperature was 90 degrees centigrade. Now calculate the temperature after 15 minutes by using the exponential function model with the help of Newton's law of cooling. And also find how long it will take to bring the water temperature down till 40 degrees centigrade. The statement says that the container of the water has been boiled up to 100 degrees centigrade, and then the container of the water has been placed in the place where the room temperature is 26 degrees centigrade. They realized that after passing 10 minutes, its temperature was 90 degrees centigrade. Now our task is to calculate the temperature after 15 minutes by using exponential function and with the help of Newton's law of cooling, and also to find how long it will take to bring the water temperature down till 40 degrees centigrade. Two challenges. One is to calculate the temperature after 15 minutes and the other challenge is how much time it will take when the temperature is 40 degrees centigrade. Solution. From Newton's law of cooling, which is T of t equals to T sub naught plus T sub 1 minus T sub naught into e to the minus kt. It is a typical equation of Newton's law of cooling differential equation, where this capital T is the temperature and the small t is the time. T sub naught is the room temperature, which is 26 degrees centigrade, and T sub 1 is the boiling temperature, 100 degrees centigrade. Just substitute the values here. So my equation is 26 plus 100 minus 26 into e to the minus kg. Simplify the equation to have 26 plus 74 times e to the minus kt. Now to find the constant of proportionality, which is k. It's from the initial condition t equals to 90 degrees centigrade. When you look to the statement, my initial condition is that after passing 10 minutes the temperature was 90 degrees centigrade. Just apply this first condition and put the temperature value and the time, which is 90 and 10. Simplify the equation to have e to the minus 10k equals to 0.8649. Take natural log on both sides, where natural log will cancel with the e, and I am left with minus 10k equals to minus 0.1451. Rearrange the equation to have k equals to 0.01451. This is the value of k. Just put the value of k here. So my first challenge is calculate the temperature after 15 minutes. Therefore I'm going to put the value of t equals to 15 here. Just put the value of t equals to 15 here. And simplify the equation further to have t equals to 85 degrees centigrade. So this is going to be my temperature after 15 minutes. This was my first challenge. And the other challenge is to find that how much time it will take to bring the water temperature down till 40 degrees centigrade. Put the same equation here, t of t equals to 26 plus 74 times e to the minus 0.01451 times t, where the temperature t of t equals to 40 degrees centigrade. Just substitute the value of t of t equals to 40 degrees centigrade here. My task is to find the value of small t, which is the time. Just simplify the equation to have e to the minus 0.01451 times t equals to 0.1892. And then after taking natural log on both sides, I have minus 0.01451 times t equals to minus 1.665. Rearrange the equation so I have t equals to 115, which equals to 1 hour 55 minutes. So it will take 1 hour and 55 minutes to bring the water temperature down till 40 degrees centigrade. Having said that, it is one example of Newton's law of cooling. You can search for many other samples and you can solve it by using Newton's law of cooling, which is a simple ordinary differential equation.